Good morning guys, I'm Chris and welcome back to this Sunday's episode of Rift Amps. Super Reverb, this is the one that the customer converted into a head and 2x12 setup. So it's come in for quite a bit of work. It's got quite a bit of noise going on, a couple of cracks and crackles and pops, thank you. The reverb control when you turn it is very noisy. Rustles and crackles and things. So I was just going through it, having a good look through, and as you do with any old Fender, do some very basic checks, things you can do. First thing you do, as I mentioned before, is you check that the board isn't conductive and that there isn't any DC, even in the millivolt range, lurking around on the board, because that causes all sorts of fun problems. So that's the first thing you check. Second thing you check is that all of the heaters are in phase, especially in the preamps. So what I mean by that, you see you've got this green twisty wire here, and you can see you've got one going to pin 9 and the other going to pins 4 and 5, which are tied together, and that's the same down 1, 2, 3, 4, 5, 6 preamp valves. And when we say they're in phase, we want all the 9s connected together, all the pin 9s, and then all of the pins 4 and 5 connected together. So even though they're twisted, 4 and 5 goes to 4 and 5 goes to 4 and 5 goes to 4 and 5, and so on, and 9, 9, 9, 9, 9, 9, all the way down the line. You'll notice in some old Marshall amps, they use different coloured wires to help get the phasing correct. So I think it was black and red. So it was easy to see, but with Fender, with the green, you've got to really be careful. You can introduce all sorts of fun noises and hum and things if your heaters are out of phase, and that was the case with this amp. As I went down the line, I noticed that V2, V4 and V5 were out of phase with the rest of them. So I've desoldered and I've moved the wires into the right place, and that means our heater string is now fully in phase all the way down. And you know what? It's made one hell of a difference. This amp is surprisingly quieter now than it was previously. Although I did find on V6 that one of the heater wires wasn't actually soldered and it was just loose in there. So that could have been a source of some popping. Anyway, now confident enough to fire it up on the bench, which I've done. It is a US voltage model, so I've got the step-down transformer running. Fire it up through the light bulb limiter, all good, and now we're up and running. It's been on for about 20 minutes. We're going to do a power test. Now, Super Reverbs are 40 watts into 2 ohms, which means I've had to dig out the old 2 ohm dummy load, which rarely comes out, but here we are. And it means when we do our power measurement, we actually get to use the 2 ohm stack, find out where we are. So I'm driving input 1 on the vibrato channel, treble on 0, mid on full, bass on 0. And we're going to advance the control. I've got the bright cap out of circuit. We're going to advance the control up on the scope. There's our output sine wave. Looks really nice actually. We'll bring it all the way up just to the point of clipping. We'll call it there. My scope's reading 8.8 volts. We'll call it 9 volts. Now, 9 volts into 2 ohms is there, 40.5 watts. Okay, how does that work? Well, you take your voltage in AC, you square it, then divide it by your load. So 9 times 9 is 81, divided by 2, because it's 2 ohms, gives us 40.5. So we are getting 40 watts into 2 ohms. Okay, and actually that sine wave, that looks really nice. That's a beautiful sine wave. Okay, so that's this channel. We'll try the normal channel. Now this channel does not have a mic control. And you can see we've got our sine wave there. Find the point where it breaks up. Slightly lower on this one, 8.5, which puts us at 36 watts. So they're both performing pretty close. We're almost there. You know, what's a few watts between friends, eh? So, that's interesting. We'll go back to vibrato channel. And if I advance, well, let's go back to rated output. Let's get 9 volts on the... There it is. This pot needs to go clean. Here it is. If I advance the treble control, watch what happens. The output drops. Now we're getting some funny things going on. Okay. See that? When I advance that treble control, we shouldn't get an output drop. It's acting like a reverse master volume. Now, we've seen this before. So let's put our treble, middle and bass on 5. There's our output sine wave. It's starting to do some weird things now. Not happy at all. I think there's an issue with the volume. Pot needs to go clean. So I'm just messing around with it, and we're getting cutouts and all sorts. So that's going to need a good old service. And then we need to find out why the tone stack isn't performing properly. So we'll take some measurements, some voltage measurements inside the amp, check the solder joints along the pots, all the common things like that, and take it from there. The other issue was, of course, the reverb control. Tell you what I'll do. With the all the controls at 0, the amp is quite noisy. There's a lot of hiss going on. Turn up this control and it gets worse. So this channel is definitely noisy. This channel, however, less so. It's quite nice actually. Pretty standard for Super Reverb. So I think most of the issues lie in this channel. So that's where we're going to start, or that's where we're going to focus our investigations. Now, he also said the tremolo was very, very weak, so we can trigger that. On these, the tremolo is naturally off, and you have to use the foot switch to turn it on. Now, we can use just a test lead to chassis on the well, they call it vibrato, but it is tremolo. We just connect that to ground, and we should start getting I can hear the thump. Let's go back to testing. Let's get our signal up. There it is. So we've got speed here, intensity here. Intensity on 10. It's actually quite a nice low speed on this. Usually the lowest speed is quite fast. Can you see the bulb flashing? Yes, you can. Good. Okay. So we've got lots of investigation to work out. Sorry, lots of investigation to do to work out what's going on. Let's switch the trem off. And we will go from there. But I'm going to start taking some voltage measurements, see where we currently are. And that gives us a good baseline to carry on working from. Just finished populating this Ainsley Lister signature board. So all the components are now in on the board. I need to give it a haircut, trim all those off. Then I can do my underboards, my overboards, and my flying leads. So yeah, good progress on that. Weather update. The sun's come out. Not sure if you can actually see or tell, but it's an absolutely gorgeous day today. There's the sun. It's about 19, 20 degrees Celsius here. It's gorgeous. I haven't had to put the heating on. I've got my t-shirt back on. No jumper needed. Got the window open, look. So yeah, complete change in fortunes for the weather. And I did, around somewhere, see Tremolo Cat earlier. I don't know where she's gone. Just burning in this PR50 build, lovely sine wave on the scope. Really, really happy with the way this one's turned out. For those that don't know, my PR50 is volume, treble, middle, bass, and then 2-knob reverb. So no tremolo in this one. Running really nicely. 6L6s, of course. I always say it's a soft 50 watts, so it's not like the big 50 watt Fenders. That style of amplifier. This one's got a softer, sweeter feel to it. So it's an upgrade over the 35 that I do. So it's the next stage up, but we do treble, middle, bass, and 2-knob reverb, no tremolo. So yeah, that one's burning in nicely. It's been going for a couple of hours now. Really happy with it. And I need to get this one in the cabinet and shipped off to the customer. Little bit of progress on the Super Reverb. So I thought I would just start with some of the easiest stuff first. Now, do you remember the reverb control was extremely noisy when you turned it? Well, not anymore. So trace the fault to the 3 nanofarad capacitor that is the coupling cap to the reverb control itself. Fitted a new one that we had roughly 20 millivolts on the pot, which is where the scratchiness was coming from. So nice and easy. Replace the cap. DC disappeared, but the control was still slightly noisy in a different way. Turned out there was a cold solder joint on the ground strap there. So reflowed that, and now it's all good. Excellent news. The other issue that we had, we go back to our load, insert a signal, was, do you remember on the normal channel, there's our signal, if we turn the treble control up, it acted like a reverse master volume. Well, as you can see now, it doesn't. It's working as it should. Two causes of that. Again, same as the reverb control. So the treble cap in the tone stack, the 250 microfarad cap, it's this one. Very leaky, over 100 millivolts leaking from that cap. Replace that cap, and then one of the solder joints on the pot itself again needed reflowing, and that has now rectified that issue. But also I found that both the treble and the bass pots were, no, sorry, the mid and the bass pots were loose, very loose indeed. So took the knobs off, tightened those up, back together, and we're all good. So that's those issues sorted. The only thing is that this volume control here still has a tiny bit of rustling as you turn it. There is now 0 DC on the pot itself, and I've given it a good old clean, but it's still a tiny bit there. So I might talk to the customer about either removing it, stripping it down and giving it a proper clean out, or whether we just fit a replacement. We'll have a further think on that, but honestly the rustling is so quiet, it's barely audible. So yeah, it's going to have to make a call on that at some point. Anyway, so we'll come back to our speaker so I can hear the amp again. It's still got quite a bit of background noise and hiss that you can hear going on. And I need to identify where that's coming from. But the main issue, of course, is the tremolo that's thumping. If I just trigger the tremolo. The thumping is independent of the volume controls, as expected. Turn the tremolo speed up. The thumping is there. I'm not sure if this is coming across, but trust me, it's there. Did a bit of chopsticking around. As we mentioned before, it's already had the 10 nanofarad cap from the roach to ground installed. Obviously that's not having an effect because the thump is still there. However, I might be tempted just to remove that to see what effect it has, if any, in case that's masking a different issue. I've had a good chopstick around with trying to move lead dress around, see if any of these wires affect anything. No, it doesn't. So We're not looking good at the moment, but I am cracking on with this, making progress, but I do need to spend some time on some other bits. And the second of the Marshall heads that I need to get looking at, this is a 1978 or circa 1978 Marshall JMP50 master volume model, vertical input. This originally was a 2x12 combo that the customer converted into a head setup. I think that's a really good idea because those 2x12s weigh an absolute ton, and if you need to put it back, all you've got to do is swap the chassis back into the old cabinet. So what's this in for? It's just a service and a check over. Make sure it's running as it should. No real customer complaints. Just wants to make sure that it's running as it should. There's no issues with it, that any previous work that's been done is to a high standard, and I'm to rectify anything that's not, and just make sure this thing is giggable. Here we go then, and as proof, not that you need it, 50 watt master volume combo, June 1978. Very nice. Okay, so obviously we can see it's got some replacement filter caps in it, F&Ts. They've been done, but it looks like it's got the original transformer set, including, is that a Drake? Yes, it is. Drake choke. Okay. Let's flip this thing over. Have a look inside. Okay, I've just been looking online. I found a schematic for the amp. So obviously this was the 2x12 combo version of the head. Now the head is model number 2204, which is the one that everyone wanted. And I think it's the 2104 model is the combo. That's the only difference. So I'm just having a look throughout. I can see the work on the cap replacement, not bad. Having a look, someone's added some hold on a minute. 1, 2, 3, 4. Yeah, so they've added some screen stoppers, 1K5 screen stoppers, but they don't look like 5 watters to me. So maybe they're not right. At least they're elevated away from the socket. Not bad, eh? Because as you can see on this one as well, oh, this is saying 1Ks. So why have they put 1K5s in? Were the screens over dissipating, or is that all they had? We don't know. We'll never know. Anyway, let's have a look. I can also see some diodes from plate to ground on each socket. Not sure that's factory. It may well be. I'll have to look at some pictures online. If you do know, put it in the comments down below. That would be great. Bias caps replaced. That's excellent. That's what we need. And having a look around, the rest of it, pretty standard. Okay. Okay, so first thing I need to do with this then is give it a play test. See if I can hear anything that's wrong with it or not quite right. Then we'll get it on the test bench, take some measurements and voltages. You know the score by now, not difficult, but there you go. I know it's upside down, but master model 50 watt Mark II lead. This one obviously is running EL34s, but I think the American ones had 6550s in. Might be wrong, correct me again. But here's the schematic, just having a look at it. All pretty standard. Love it. Update on the Bassman. Customer has approved the recommended work, which I said to him, I want to return this to stock. So it operates as originally intended. Then once I've got there, then we can, go through it and see what else it needs. But I suspect, looking at the standard of work in some areas and the standard of work in others, that this has been the result of numerous techs working on this over the years. So yeah, I'm not confident that this is the fault of just one person. Some of the work in here is okay, pro level work maybe. Some of the other work definitely isn't. So more hobbyist spec. So I would be surprised. But anyway, I'm going to I want to pull the bias board. I mean, I'm not happy with the way those diodes are installed. They're probably okay, but it's not up to my spec. Not happy with that. For some reason, he's disconnected the heater center tap and has gone for the 200 ohm artificial resistors there. There are pros and cons of each method, but I prefer a center tap anyway. But yeah, that's just me. That's all that. So yeah, I'm just going to go through it, do my thing. Customers authorized a certain amount of time for me to spend on it, and we'll take it from there. But as this has been, this channel here, the bass channel, has been turned into like a pseudo Marshall channel, but they haven't done a very good job of it. So we're going to get rid of that, put it back to stock, get this thing going as it should be, sort out these super excessive flying shielding wires. Absolutely no need for that. Go through it and see what we can find, and just make this thing good, because that's what it needs and deserves. So that's the plan on that. I estimate roughly I'm going to be spending probably about 3 hours on this, and then we'll take it from there. And this is one of the Fender 64 Deluxe Reverb hand-wired reissues. Now, this is the first one that I've had in the shop. I've had the Princeton, but I've not had the Deluxe Reverb. So interesting to see inside, accompanied by a note from the customer. Hi Chris, finally got a rush job. It's a bit of a rush job, but please excuse the packing. I usually do a better job than this. Hope it arrives safely. Well, yeah, it did. Anyway, enclosed, I can't talk today. Enclosed is the chassis from the 64 Deluxe Reverb. Custom Deluxe Reverb. I'm finding it a tad noisy and a little bit flat sounding. I'd be glad if you could give it a full MOT, including any improvements, updates you think it would benefit from. I'd also be interested in switching it to using 6L6s if you found that to be possible. Okay, so I know it's possible on the vintage models, but can we do it on this amp? We'll need to see what the transformers can do. Now, I have to say that opening up for the first time, the work inside does not look nearly as professional, neat and tidy as the work I see in your videos for your own amps. I'm still thinking about purchasing one of your amps, having problems deciding which one, but that is a work in progress. In the meantime, please stick this in your queue and let me know if you do need any input regarding what you feel you want to do. Like yourself, I'm pretty fond of my coffee, so enclosed also is a small bag of beans. I have no idea what they're like. You're a bit of a guinea pig here, but hopefully you'll find them okay. Well, I've already ground some up and they taste fantastic, so thank you very much for those. It was a bag of packed coffee, one of the roasters here in the UK. Absolutely love it. Fantastic. So here's the amp. Now, some of the viewers may have seen these on other text channels, and they've probably gone into more detail on this amp than I ever would, because as we know, this is more of a workshop diary format channel rather than a dedicated tech channel. So, but I don't really know much about these other than I know Fender were trying to get back into the boutique market with these things, but I'm trying to be polite, but I'm not sure you could call that hand-wired. I mean, it probably was done by hand-wired, but not to the standard. I mean, I've seen 70s Fenders that are better than that. But anyway, that's beside the point. It is what it is, and we'll do what we can do. So what do I notice? Having a look around, seeing lots of things. They've got these very expensive Fender branded caps, which I don't think are worth the money, but again, beside the point. So what can we see? Can we see anything that stands out? Bear in mind, I'm looking at this for the first time on camera. anode wire from the reverb transformer, this blue one here, is in parallel with the other anode, which is standard for a reverb driver, but they're going over the socket with a bare wire, and there's not a lot of clearance to the cathode connection underneath, the cathode jumper. Now, anyone who knows anything about Fender amplifiers, especially reverb drivers, that this jump over wire has to loop around the socket and come this way, otherwise you can get some awful blocking distortion in the reverb. So that's no good, is it? So we're going to have to rectify that, because I bet that's causing a problem. The anode and the grid and the cathode wires can go across the socket. It's the anode, the one that has to go around. So we'll rectify that. Let's look at V1 and V2. Do we think this is going to be a source for noise? Do we think these wires have been laid out in a way that are going to reduce noise and be quiet in operation? I haven't powered this amp up yet, so I don't know. They may have got lucky, but I'm not sure. Anode. Where's the coupling cap? There's normally like a 47 nanofarad coupling cap here, and then that wire goes all the way to the phase inverter, but the phase inverter has only got one input. Oh, I see. So they're mixing this channel so you get reverb on both channels. Okay, interesting. But still no coupling cap, and they're connecting it to the anode of V2B. What? Let me just double check that. And this is your reverb in. Here's your reverb cap. So this wire goes to your reverb input on this socket, the grid of there. So hold on a minute. V2B gets its own coupling cap before the reverb stage, but V1B doesn't. That's not good. Ideally, what you want is, if you're going to mix both the channels, you want both channels to be decoupled and then mixed together with mixer resistors into that stage. Although you can do it without mixer resistors and just go straight into there. But that's not the best way of doing it. That's odd, isn't it? Why have they done it that way? I bet that doesn't sound good at all. Okay, so that's something to look at. I bet if I go online, somebody else has spotted that already. Can we see anything else? I'm sure if we look hard enough we can. Brass grounding plate. Okay, so that's the inside of the amp anyway. So again, the customer wants me just to go through it, do my thing, get this thing nice and quiet. As to why it's sounding, what does he say? A little bit flat sounding, so a little bit anemic. Well, we'll have to look, see what we can do about that. Fire it off on the bench, see what the sine wave and the spectrum looks like, and take it from there. But yeah, that's a Fender 64 hand-wired custom deluxe reverb. Yeah. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up. All your comments and questions down below. Subscribe if you haven't already. Hit the notification bell. If you're feeling super generous like these guys were, please join the channel. And I will catch you all at the next one. A little bit of bonus footage for you guys. So, as you know, I am an avid circuit racer. I drive a Mark 1 Mazda MX-5 Miata that is built for endurance racing. So it's not got the standard 1.6 engine, it's got the later 1.8 VVT engine in it, various hosts of other upgrades and things, and it's a front-running car in the class that I race in. Now, as I mentioned in the last video, the last race at Silverstone and the race at Silverstone before that, I was in the lead of my class on the final lap both times, and the car broke down on me. Now, after the first race, looking back at the footage, we could see the engine was clearly misfiring. And in that system, it's a wasted spark system, which means that 2 ignition coils fire at one time, numbers 1 and 4, then 2 and 3. I can't do that with my fingers. Then 1 and 4, then 2 and 3. So when an ignition coils go down, 2 cylinders go down. So that's why we thought it was an ignition problem. So I went ahead and I replaced all the ignition components, spark plugs, leads, coils. I did a new ignition loom as well, made that up. Fitted that to the car. Now, because obviously it's a race car, I can't drive this thing on the road. So I can't just take it out and test it. The only time I can test it is if I go on a track day or an official test day, or in the race itself. It is difficult, with time limitations and budget restraints as well, and all those things. It just wasn't possible. So it turned up at the next race, and I was leading going into the final corner, and the car did exactly the same thing. Now, as I'd replaced all the ignition components, I thought, well, if it's not ignition, it's got to be fuel, right? And as I said this on the video, that maybe there's what my suspicion was, that as the fuel level gets too low, the fuel pump itself is no longer submerged, even though the pickup sits very low in the tank. It sits at the lowest point, so that's always got a fuel feed. And because it's a return system, any fuel that's not used by the rail is dripped directly onto the pickup sock, so you don't get fuel starvation in MX-5, Mark 1 at least. So I thought, okay, well, maybe because it's not the original Mazda pump, it's an aftermarket pump, one that you buy from a Motor Factors or somewhere like that we'd fitted. Maybe as the fuel level dropped below the pump, it was no longer being cooled by the fuel, was overheating and therefore shutting off. That was my best theory. So I ordered up a high quality Deutschwerks pump, which is the same PSI, slightly higher flow rate, but it won't matter for the application. And when I pulled the old pump out of the tank, and I'll put a picture online now, on the screen now, you'll see that the pump was still submerged. And here's a picture of the remaining fuel in the tank at the end of the race. So I was actually carrying more fuel than I needed. So it's not a pump overheating issue. So what could it be? What would cause quite a drastic misfire that means that the car will no longer run or drive, but after 15 minutes cooling down, the car starts up and runs absolutely fine? Well, the problem here in the UK is that the engine I'm running, the 1.8 VVT, isn't raced in competition, because the MX-5 championships and the cups, all the standard race cars run the 1.6 because that's the regulation. It's only over in America where they run the later 1.8 engines. And so I've spent a lot of times on their forums watching their race videos, trying to work out why, or see if there's a common problem. Now, this here is the camshaft position sensor, and this sits on top of the engine in the valve cover, and it measures, it's a Hall effect sensor, and there's a knob on the camshaft and it measures the rotation, so it knows the position of the camshaft, and the ECU will take that reading and one from the crankshaft position sensor to work out where the engine is at its cycle, and therefore will fire both the injectors and the spark plugs at the appropriate time. Now, in Spec Miata, they don't run aftermarket ECUs like I do, they run the stock ECU. So when there was a spate of issues with the camshaft position sensors, usually when it gets hot, so when it's heat soaked, and it would throw a code, and they'd look up the code and it'd say, you know, camshaft position sensor not working as expected. They'd fit a new sensor and it would be okay, but a couple of races later the issue would come back. And over time they've worked on solutions for this, and what they found is that it's not actually the sensor itself. The issue, as in it's not an internal fault to the sensor, the issue is the pins. And hopefully if I zoom you in you might be able to see it, the connector pins in that connector itself. And what happens is when you have the loom, and I'll get you one. Here's the loom. Here's the female connector. Those two connect together like that, and that's how it sits. And what they actually found was that as this thing heats up and gets heat soaked over time, that connector can back off ever so slightly, and at the same time, these female connectors, female pins will expand slightly, and you'll get an intermittent connection to the sensor. And when it does that, you get a 2-cylinder misfire or 2-cylinder dropout. So watching enough videos and speaking to enough people on the forums, we suspect I'm having the same issue as those guys. So what do we do? What's the fix? Apparently these pins are ever so slightly undersized compared to what they should be, and it's just enough that in competition use you can get a dropout. So the approved fix in Spec Miata racing is to solder directly to these pins and then have essentially the same connector off here, so you have a pigtail soldered in place, and that should fix everything. And rather than paying somebody a large amount of money to do this, I mean, I could get one from the States, brand new Mazda sensor with the pigtail. I mean, they're $180 plus shipping, plus taxes, plus import, all that stuff. No, not for me. I'll just make my own, and that's what I've done. So this is one that I've done. This is the sensor that was on the car when it failed. So I've done that, added my own pigtail, Tessa tape, all ready to go. And that into the plug. I'll just show you on this one again. We'll put the sensor back in. I can actually feel there's a little bit of play there. It does actually move slightly, but if I go to the upgraded connector, there's no play at all. Absolutely nothing there. I cannot get that to move. So there we go. So what I've done is I've already made up a third one, because I've actually got quite a few Mazda camshaft position sensors. I've made up a brand new one, a brand new sensor with a pigtail, and I've fitted that to the car. This is what that looks like. I've made up the old sensor as a spare, and I'm going to make this one up as a third spare, because, you know, if you want a redundancy, you've got to have a second redundancy as well. So that's what we're going to do, and that should be the fix. That should be the resolution to all of my issues. You know, I should be on 5 wins this year, and I'm only on 3. So yeah. So what I'm going to do is solder the pigtails onto there, heat shrink that down. Got to solder the other end onto the terminals, crimp on the weather sealing, seal it all in place, more heat shrink, more Tessa tape, and make up one like that. But there you go. So I think that's the cause of my problem. That's a nice job to do in the evening.